Hello friends, welcome to the session. See the continuation of chapter 4, that is inverters concepts. In the last sessions I discussed about what exactly half bridge inverter, that is single phase half bridge inverter and single phase full bridge inverter. Okay. Then for different loads I drawn the different waveforms also. And I discussed what is the importance of feedback diodes, that is in voltage source inverters. Okay. All these concepts I discussed in the last sessions with respect to inverters. Okay. Then see the continuation of that concept of bridge inverters. We've seen that it may be half bridge inverter or full bridge inverter. Whatever the output voltage waveform we are getting, it is not a pure sinusoidal. Mainly I discussed about square wave inverters now. In that square wave inverters means the output voltage waveform is square wave. Yes? It is a sinusoidal or non-sinusoidal? It is a non-sinusoidal. We know that. Any non-sinusoidal waveforms are analyzed by using Fourier series. Now I want to explain Fourier analysis of single phase bridge inverter. That is full bridge inverter and half bridge inverter. But point to remember, the difference between Fourier analysis of full bridge inverter and half bridge inverter is only the output voltage. In the case of full bridge inverter, what is the output voltage we are getting? Vs. In the case of half bridge inverter, what is the output voltage we are getting? Vs by 2. Just first I will explain this. What is the Fourier analysis of full bridge inverter? In that formulas, you replace Vs by 2, then that formulas are related for half bridge inverter. Simply remember like that. Clear? Okay. Shall we start? You write down, that is a Fourier analysis of single phase bridge inverters. That is Fourier analysis of, write down, Fourier analysis of Fourier analysis of single phase bridge inverters. Bridge inverter. Fourier analysis of single phase bridge inverter. Okay. Under this concept, I want to discuss for single phase full bridge inverter. This I am discussing Fourier analysis of single phase full bridge inverter. Single phase full bridge inverter. Single phase full bridge inverter. Yes, first we'll start with single phase full bridge inverter. In these formulas you replace Vs by 2, then we can get Fourier analysis for half bridge. That's the only difference. Okay, we know that. Let us consider the output voltage waveform of full bridge inverter. We know that if this full bridge inverter is operated in square wave mode, if this full bridge inverter is operated in square wave mode, then what is the output waveform we are getting? Let this instantaneous output voltage is V0. We are getting square waveform. This waveform you know. And this is the output voltage waveform. Let this is pi, this is 2 pi and this is 3 pi. Let this is plus Vs and this is minus Vs. Okay. Full bridge inverter means at a time how many switches are conducting? 2 switches. Here S1, S2 is conducting, this S3, S4, again S1, S2 is conducting. Is it a pure sinusoidal? No, it is a non-sinusoidal waveform. Any non-sinusoidal waveforms are analyzed using Fourier series. That means it is a non-sinusoidal. It is non-sinusoidal. Non-sinusoidal. It is non-sinusoidal waveform. Non-sinusoidal. And it is analyzed. And it is analyzed. Tell me. By applying Fourier analysis. By applying Fourier analysis. By applying Fourier analysis. Or by applying Fourier series. That point is. Now, this is square waveform. Can you tell me what is the RMS output voltage of this waveform? That I already calculated. V0 RMS equal to Vs. Because of square waveform, that you can get constant. V0 RMS equal to Vs. It is non-sinusoidal and it is analyzed by applying Fourier series or Fourier analysis. We know that according to Fourier analysis, any function, then according to Fourier analysis, the instantaneous output voltage V0 equal to A0 plus summation n equal to 1 to up to infinity an cos n omega t plus summation n equal to 1 to infinity bn sin n omega t. This you know. This is the instantaneous output voltage representation according to Fourier series. Now we calculate what is the instantaneous output voltage of this waveform. We want to calculate what is A0, what is An and what is the Bn. Tell me. Whatever the waveform we are getting in a full bridge inverter, it is a symmetrical waveform. Because of symmetry, what is this A0 is called? A0 is DC and it is average. This value equal to 0 because of symmetrical. Then you know the formulas of An and Bn. That clearly I explained even in the rectifiers also. How to calculate An and how to calculate Bn. Then by applying that Fourier analysis formulas, once again no need to do that analysis here. Directly I am giving. The value of An equal to 0 for all values of n. For all values of n. For all values of n, this is equal to 0. Then what about Bn? If you calculate Bn for this waveform, this Bn equal to 0 for n equal to, you take this even values, n equal to 2, 4, 6 and so on. Then this Bn value equal to 4 Vs by n pi. This is for n equal to 1, 3, 5 and so on. Now substitute A0, An and Bn values. Let this is equation 1. By substituting A0, An and Bn in equation 1, by substituting A0, An and Bn, A0, An and Bn in equation 1, then what you get? The instantaneous output voltage V0 equal to, this is 0 and this term is also 0. Then you substitute here. This is defined only for which harmonics? Odd harmonics. Then what you can get? Summation n equal to 135 up to infinity 4 Vs by n pi sin n omega t. This is the instantaneous output voltage of full bridge inverter. This is very important, 5 star. Once you can remember this relation, from this relation you write any formula. The instantaneous output voltage V0 equal to summation n equal to 135, because it is defined only for odd harmonics. Up to infinity 4 Vs by n pi sin n omega t. Try to write parallelly. Okay. Then this is the instantaneous output voltage. Now from this you can list out any formula. That is important for competitive. Now tell me, from this relation, can you write what is the maximum value of nth harmonic output voltage? From this you write any formula. I am writing different formulas here. Maximum value of nth harmonic output voltage. Maximum value of nth harmonic output voltage. Nth harmonic output voltage. How much? This indicates, except function, this indicates maximum value. This is, I am denoting with V0 Nm, that is 4 Vs by n pi. Don't concentrate on notation, you concentrate on term. That is maximum value of nth harmonic output voltage equal to 4 Vs by n pi. Can you tell me, what is the RMS value of nth harmonic output voltage? RMS value of nth harmonic output voltage. Nth harmonic, okay, output voltage. RMS value of nth harmonic output voltage. That is V0 Nr is equal to V0 Nm by root 2. Then how much you get? 2 root 2 by n pi into Vs. Maximum by root 2, that gives the RMS value. Next, RMS value of fundamental output voltage. RMS value of fundamental output. That you tell me, fundamental output. Fundamental output voltage. Okay. How much you get? RMS value of fundamental means n equal to 1. Fundamental output voltage. V01 equal to 2 root 2 by pi into Vs. This 2 root 2 by pi value is also written as 0.9 Vs. This RMS. Every formula, every relation is important. Don't think like this, we are by hearting all these formulas. You think like this, you are writing the formulas by your own, by knowing this equation only. You remember this one, no need to by heart all this one. If any question is asked, from that you can write the formula, then you can answer. Like that, that approach is important for competitive. Every formula by hearting, that is not good. Yes? Next. This RMS value of fundamental output voltage, that is 0.9 Vs. Tell me, what is a distortion factor? A distortion factor. How to write a distortion factor? Here distortion factor means we are talking about voltage distortion factor, because we are analyzing the voltage waveform. Voltage distortion factor, that is DF. The fundamental definition of distortion factor is fundamental by total RMS. What is the fundamental? V01. What is the total RMS? V0 RMS. This is the distortion factor. At the starting I given what is the definition of distortion factor? Fundamental by total RMS. Then what is the total harmonic distortion? THD. 1 by df square minus 1 whole to the power of 1 by 2. This relation also already given. 1 by distortion factor square minus 1 whole to the power of 1 by 2. This is the total harmonic. Next, tell me. Load power, output power or load power. How we can write? P naught equal to V naught RMS square by R. Shall we write fundamental output power? Fundamental output power. That is power delivered due to fundamental component. Fundamental output power. Okay. How to write the formula, you tell me? Then P naught 1 equal to V naught 1 square by R. That is the fundamental output. That is power delivered due to fundamental component. Then I am writing. This is the instantaneous output voltage. Now, this equation indicates instantaneous output voltage. Now I want to write the formula. Instantaneous output current I naught equal to. Then how to write? Summation. N equal to 135 up to infinity. You want to write the expression for current now? 4 Vs by N pi. That you take Zn sin of N omega t plus or minus theta n. This is the expression for instantaneous output current. Yes. I naught equal to summation N equal to 135 up to infinity 4 Vs by N pi Zn sin of N omega t plus or minus theta n. Why you taken plus or minus theta n means we know that based on the load parameters the current may be lagging or leading. That is positive for this one, positive for leading. This you take negative for lagging current. Okay. Then what is Zn here? Zn equal to square root of, let us assume that it is RLC load, R square plus N into omega L minus 1 by N into omega C whole square. This is for which one? This is for RLC load. Okay, RLC load. Yes, we also define theta n. Then what is theta n, you tell me? The value of theta n equal to tan inverse N into omega L minus 1 by N into omega C by R. This also for which load? RLC load. This is instantaneous output current 4 Vs by N pi into Zn sin of N omega t plus or minus theta n. This is Zn value. This is for RLC load, that is theta n. If it is a resistive load, neglect inductance and capacitance. If it is RL load, neglect capacitance. If it is RC load, neglect inductance. Like that we can make assumptions. Okay. One point to remember here, this instantaneous output voltage now, this equation you also write like this, 4 Vs by, if you substitute N equal to 1 pi, that is 4 Vs by, that is you write N equal to 1 na, 4 Vs by pi sin omega t plus 4 Vs by 3 pi sin 3 omega t. Like this also we can extend. This is first order harmonic. This is the fundamental component. This is fundamental. This is third order harmonic. Next, fifth order. Like that we can extend. Okay. These points you remember with respect to full bridge inverter, single phase full bridge. For example, I want to calculate one more formula I am writing here, 9th one. I want to calculate V0 5 by V0 1. Then how to calculate fifth harmonic output with respect to fundamental. What is the fifth order harmonic? 4 Vs by 5 pi by 4 Vs by pi. If you want percentage into 100, how much percentage you get to tell me? That is 20%. Like this. Any formula we can write. Okay, this is about Fourier analysis of single phase full bridge inverter. Now based on this, here I want to make 3 important observations here, that also I want to write. First you note down this. Quick note down. See, all these formulas we are writing by remembering this one only. That point to remember. We are not by heart. Quick. Let's see. Case 1. For purely R load, purely resistive load. Okay. How to write? Nth order harmonic current. Nth order harmonic current. Let this is IN. Let IN is nth order harmonic current. But you take as a maximum. Okay. Nth order harmonic current. At 4 Vs by N pi R. That is, we have taken Zn equal to R. Neglected inductance and capacitance, you taken the purely resistive load. Then nth order harmonic current IN equal to. Then what is 4 Vs by pi R, you tell me? Yes, fundamental current. Then the fundamental current is, let this is I. This is I by N. That means for purely resistive load, nth order harmonic current equal to 1 by N times of fundamental current. For example, what is the third order harmonic current? I3 equal to I by 3. What is the fifth order harmonic current? I by 5. That like this you remember. Then what is I here? This I is fundamental current. Fundamental. That gives fundamental. Okay. That is case 1. This is very important relation. This is for purely resistive load. You concentrate on case 2. Purely L load. Purely L load. Now you tell me. If it is a purely inductive load, then how to write? Nth order harmonic current IN equal to 4 Vs by N pi. What is the Zn, you tell me? R square plus N into omega L minus 1 by N into omega C. Purely inductive load means resistance is neglected. This capacitance is also neglected. This is whole square, na? This total is whole square. Na? Then what you get? Nth order harmonic current equal to 4 Vs by N pi into, this is N into omega L. This square and root is cancelled, that you can get. This R is neglected, na? Capacitance is neglected, na? That is N omega L whole square. Na? This square and root is cancelled. Then what you can get? N omega L. Then from this, what is 4 Vs by N square pi. Omega L is nothing but XL. Then what this current, you tell me? Fundamental current for purely inductive load. For purely inductive load, fundamental current equal to 4 Vs by pi XL. For purely resistive load, the fundamental current equal to 4 Vs by pi R. Shall we write like this? This is I by N square. Therefore, for purely inductive load, nth order harmonic current equal to I by N square. 1 by N square times of fundamental current. Clear? Resistive load means 1 by N times. Purely inductive load means 1 by n square times. This is case 2. This I want to explain case 3, that you concentrate on case 3. Case 3. Tell me. If it is purely capacitive load, purely C load, purely capacitive load. Purely capacitive load means, tell me, what is the nth order harmonic current IN equal to? 4 Vs by n pi. What is the Zn you are writing? Square root of R square plus n omega L minus 1 by n into omega C whole square. Purely capacitive load means neglect resistance, neglect inductor. This 1 by n omega C whole square. Whole square. Root and square is cancelled. Then what you get, you tell me. Then nth order harmonic current equal to 4 Vs by n pi into 1 by n omega C. This n cancel. Then what is nth order harmonic current? Nth order harmonic current equal to 4 Vs by pi into this 1 by omega C. This 1 by omega C means, that is 4 Vs by 1 by omega C is nothing but a Xc. Then what this current? 4 Vs by pi into Xc. That is a fundamental current for purely capacitive load. This is IN equal to I. Therefore, for purely capacitive load, nth order harmonic current equal to fundamental current. For purely capacitive load, nth order harmonic current equal to fundamental current. See the observation here. If it is a purely resistive load, nth order harmonic current equal to 1 by times of fundamental, 1 by n times of fundamental. If it is purely inductive load, nth order harmonic current equal to 1 by n square times of fundamental current. If it is a purely capacitive load, nth order harmonic current equal to fundamental current. Clear? Note down this. Note down. Quick. Yes. Okay. Now see. This about Fourier analysis of full bridge inverter and the related formulas and related observations that you concentrate. Okay. Now I want to explain what is the Fourier analysis of half bridge inverter that you concentrate. That is, what is the Fourier analysis of single phase half bridge inverter. Single phase half bridge inverter. Yes. In the Fourier analysis of single phase half bridge inverter means, we know that at a time, how many devices are conducting? Only one device is conducting. Okay. Let here S1, this is S2, again S1 is conducting. We know that in a half bridge inverter, we are getting output voltage equal to Vs by 2. This is minus Vs by 2. Then, if you calculate what is the RMS output voltage of this waveform, then you get RMS output voltage equal to, it is a square waveform now. This you can get Vs by 2. V naught RMS equal to Vs by 2. Whatever the output waveform we are getting in half bridge inverter also, this is sinusoidal or non-sinusoidal? Non-sinusoidal. We know that any non-sinusoidal waveforms are analyzed by using Fourier series. It is non-sinusoidal and it is analyzed by applying Fourier analysis. Then according to Fourier analysis, the instantaneous output voltage A naught plus summation n equal to 1 to infinity A n cos n omega t. Summation n equal to 1 to infinity Bn sin n omega t. Because of symmetrical waveform, its average value is 0. We are applying Fourier series for this waveform. An equals 0 for all values of n, Bn equals 0 for even, Bn equals, replace Vs by Vs by 2, then what you can get here? 2 Vs by n pi. This is only difference between full bridge and half bridge. Where we are getting 4 Vs by n pi, here we are getting 2 Vs by n pi. Then by substituting A0, An and Bn in equation 1, replace Vs by Vs by 2. This what you can get? 2 Vs by n pi. 2 Vs by n pi. Summation n equal to 135 up to infinity sin n omega. Then this we get for different values of n, 2 Vs by pi, 2 Vs by 3 pi sin 3 omega t plus and so on. Then maximum value of nth harmonic output voltage, how much you get to tell me? This is 2 Vs by n pi. Maximum value of nth harmonic output voltage is equal to 2 Vs by n pi. Then RMS value of nth harmonic output voltage, this we can get root 2 Vs by n pi. That is 2 Vs by n pi by root 2 na, that is root 2 Vs by n pi. RMS value of fundamental output voltage, how much you can get? Root 2 by pi into Vs. What the root 2 by pi value that you tell me? That is 0.45. This is 0.45 Vs. Distortion factor, same formula. Fundamental by total RMS. Total harmonic distortion, 1 by distortion factor square minus 1 whole to the power of 1 by 2. Load power, that is total load power means you want to take the total RMS. Fundamental output power means you take the P01 by V01 square by R. You take only fundamental RMS output voltage. Then I0 equal to summation n equal to 135 up to infinity na. Replace Vs by Vs by 2. If you replace Vs by Vs by 2 means how much you can get? 2 Vs by n pi into Zn sin of n omega t plus or minus theta n. And this formula is same. Positive for leading, negative for lagging. Then this formula is also same. Theta n equal tan inverse n into omega L minus 1 by n into omega C by R. This is for RL0. Yes. This is same. 2 Vs by 5 pi. That is 2 Vs by pi. This percentage is same. 20%. Now we'll see in different cases means. For purely resistive load, then what you can get? Instead of 4 Vs by n pi R, then we get this is 2 Vs by n pi R. Because it is a half bridge inverter na, replace Vs by Vs by 2. Then remaining is as it is. This formula is same. In equal to I by n. Then for purely L load, purely inductive load na, purely inductive load. Then In equal to, then what you can substitute here? 2 Vs by n pi. What is Zn? Square root of R square plus n into omega L minus 1. Then resistor and capacitor is neglected. This what you can get? Vs equal to Vs by 2 na? 2 Vs. This also 2 Vs. And this formula is same. That is, for purely inductive load, then we are getting nth order harmonic current equal to I by n square. Replace Vs by Vs by 2. Okay. Now see, for purely capacitive load, then what you can get? Replace Vs by Vs by 2 now, because it is half bridge inverter. I am explaining Fourier analysis for half bridge inverter. This also you can replace 4 Vs by 2 Vs. Then 4 Vs by 2 Vs. Then we can get like this. This is Fourier analysis of which inverter? Single phase half bridge inverter. This you know. Simply you write one statement. Instead of replacing all these, simply you write like this also. No need to remember separately for half bridge and full bridge inverter. You write one statement like this. In the above formulas, replace Vs by Vs by 2, then we can get Fourier analysis for half bridge inverter. Understand? No. If you want to write one statement, means like that you can write, or otherwise you can note down all these formulas once again. This is a Fourier analysis of which one? Full bridge inverter and half bridge inverter. Let's concentrate quick. What exactly? Analysis of half bridge inverter and full bridge inverter. With this, the concept of Fourier analysis is completed. Okay. So that you concentrate on these formulas. Every formula is important for any competitive point of view. Okay. I stop this session with this. This session is completed with respect to Fourier analysis. Okay. Based on the previous sessions, what I discussed, I given some introduction to VSI and CSI. I clearly explained what is half bridge inverter and full bridge inverter, that I explained. And this is the Fourier analysis for half bridge inverter and full bridge inverter. Okay. Now, with this knowledge, in the next session, we'll continue with some examples, some classroom workbook, then other models of questions also we can solve. Then up to this, you concentrate on all these formulas, full bridge and half bridge inverter. The only difference between full bridge and half bridge is, in full bridge we can get 4 Vs by n pi. Here we are getting 2 Vs by n pi. Understood? Yeah. Then simply remember like this, in 4 Vs by n pi, replace Vs by Vs by 2, then you can get the half bridge. Clear? Okay. In the next session, I will continue with some examples, some problems in classroom workbook questions. Classroom workbook problems we will solve also. Okay. That you concentrate. Still anybody not note down? That clearly note down this one. Then we'll continue in the next session.